So far we have plotted and visualized the surface using 3D mesh grid. That were actually these surfaces were following some functions, equations, and we were plotting them. So in this video we will be just exploring the 2D mesh grid and plotting using 2D mesh grid. And in this video we're not gonna give functions. We are gonna just give surfaces that are real, actual, like Earth surface that doesn't follow an equation. So the elevation would be totally different, random. So we'll be also be able to actually code for random functions and random elevation. So in order to first of all get the elevation, we're going to get it from Google Map. Let's start it and first choose an area, hilly area. Okay, let's choose this area. Okay, now we have to choose a number of plots, points to get elevation, those points. So first you need to click on this add path. First I'm going to create a variable called path and just take picture first. Taking pictures, I'm gonna just click and hold this road. Okay, I'm taking this area. So in this one, you can hold and choose as much as possible. Let's send as much as possible. We don't actually intro it so too far. And as possible listening. Okay, after just wait these points. After that, just click OK, and on the path, just save this as KML file. Name it anything. After saving it, you just go to a site called as GPS Visualizer and open the elevation data. Click on this one and choose this file which is created and convert it into plain text file. Okay, connecting, it will take some time because it's very big file. So open it up and there are a number of points. So now open Excel, open this file, do next, finish, delete this thing, delete this one, delete this one, let it save this. Yes, this is latitude, longitude, and these are elevation, third column. File save as, save it in download. Let's say book as Excel workbook. Now copy this one into the folder I'm going to use, and also Matlab screenshot, just copy paste the last one. I need those two things. Okay, anything else I want? Okay, let's go for it now. Here's your Excel and here's your image. So let's write a code. First thing we need to do is just load this Excel file. Book is equal to XLS read, and you're gonna write this. Okay, and just gonna write, it'll be 3 columns. Let's name it AX. That would be like book all rows, comma first column, and like latitude, longitude, and elevation. Okay, that's 3. After that's okay, it's running very fine. Save it as first. Okay, for AX we need to discretize it, normalize it, and put it in particular range. For that we're going to normalize it first. AX is equal to AX minus minimum of AX all divided by maximum of AX all minus XOR. Let's run it. It's running very fine. Let's plot it up. Plot. See how it's looking. Good. We might need to. Okay. Let's do same for event AZ. And the range we want to put them in for x and y, which that we can put them in 1 to 100. This may be 1000 elevation, 1 to 1000, and for zeros we can actually go for, there should be nothing like 0 because I'm going to use it as an index, these two things. So there should be nothing, x should not be equivalent to 0, more than 0, because index cannot be zeros. Those two would be needed for indexing. Okay, let's run it. It's running, working fine. And also index cannot be, what index I am talking about, let's me show it what I mean. An index cannot be in decimal as well, cannot be like, rows cannot be at this 0.5, rows can be only integer values. So I would put them, convert them into int, and int. For I, what I mean is that I'm going to make an elevation matrix. For that I need those indices. Okay, x comma 1. So I'm going to make elevation matrix, and it's xi comma ay. Let's not run it yet. Let's keep it, see if it is running fine. Int 64 undefined function em for int 64. Yep, it would be like this one. Let's keep it one. Okay, it's working very fine. Now what will that be equivalent? That will be equivalent to the elevation. So this matrix for different indices would be equivalent to the AZI. Okay, it's working very fine. Let's see how is EM looking. Okay, this is the elevation matrix now. Elevation points, discretized points. Now you see these are zeros. How can we get rid of these zeros? You have to interpolate this function now. So one thing I'm good at is like images. I'm going to interpolate them as if I'm interpolating an image, as if I'm actually averaging an image. Okay, there might be another function for actually interpolating this 2D mesh, 2D matrix. You can also use that thing. I'm going to use image averaging. So first of all, I'm going to need to convert this into uint 8 0 to 255. That's what it means. Int 8, if you mean int 8, it would be like minus something to plus something, and if minus, if you mean u, then it will be only positive one. So I have to convert this elevation matrix em, and I'm gonna use special. This is a very average. Here you mentioned the averaging and size of kernel, size of the matrix, how much matrix you wanna average. Let's keep it 3 for now. And let's see this image. I am show result. Too many input arguments, because maybe you, yep, or I am something wrong. So first of all, I don't need this thing. I'm doing wrong. First of all, I'll just convert this image into uint image em, that I will mention em. After that, I'm gonna average it. I had to mention I am filter. My head was somewhere else. Okay, now it will work. Yep, here's your image. 0 0 zeros. There might be something else in here. You can see everything like this. Here are the points. This is 0. So, but look at this. Elevation is like this because I took north south may not be actually matching exactly. Otherwise, should have been matching. Okay, and also the and one more thing, the origin of image start from this top left. For coordinate, it starts from surface. I'm going to go for xy coordinate mesh grid. It's going to start from this point bottom left. So I have to flip this image also, so I'm going to do that thing also later on. Okay, I'm going to flip, either I have to flip an image or I have to flip this thing. I'm going to flip this one here. Flip z comma 1, so I don't have to flip the image later on. This is the coordinate. Okay, and show f is equal to z comma 1. Okay, let's now get xy mesh grid in here. Let's see how it looks in coordinate system. Okay, xy is equal to mesh grid 1 to 100. I'm going to 1 to 100. Then I'm going to use the surf C contour, whatever you want to use. I'm going to use surf XYZ. Use surf near wants 2D mesh, so it will work very good. Yep, this is your river here. This is your hills. So this is very good. Now you're like, yeah, it's so much peaky because I haven't averaged them yet. I have to average this thing because there are some points I have got the values, but some point I don't have these values. And for that, I am gonna average for j is equal to like 1 to 10 times. I'm gonna average it, and I'm gonna also increase the size of the kernel to 5.5. Let's see how it looks like. Okay, looking nice now. A little bit better. Maybe we can go for more. Increase the kernel. Okay, looking very good. I think it's working very good. Okay, now just let's put an image. So your 3D model is here. You can say that this is your 3D model. Now what we need, we can go to extra thing in here. We can actually put an image on this thing, on this plot. Now how to do that? Let's first of all get an image in here. For that, f is equal to imread. You have to use this command to read image first, and the image is screenshot png file. Okay, then I have to crop it because I can't just use whole image. Let me show you the whole image. I'm f the whole image. I need this part that I used. So I need to crop it up first. F is equal to im crop. Right, im crop f. It will show you graphically. I chose from this point to this point. It is random. It is like by memory. Like I from this point just crop position. The next time you don't have to actually do cropping graphically. Stop it, run it. Okay, now it's running. Very good. Okay, let me first hide this thing. Let's not run this yet. Now I need to resize it. Let's see what is the size of f. F is 550, 715.3. I have to resize it into 100 to actually match it over it. F is going to I am resize f in 100. Let's see if it works. I don't have to mention third one. Okay, f 103 into unit. Okay, it's working very fair. Let me see the image now. Okay, hill here, in middle there is this river. Okay, we had done this one also. So now we have to put this over our model. So we are going to use warp function. We mention x, y, and z, and put image f on top. Okay, here should be said. And let me run this one now. Okay, there's here 3D model. River is flowing exactly low elevation. It is like low, a little bit low. Mountains here and here. So this is your 3D model that has been generated by using data elevation points from the Google, thank you for watching.